We've already learned that the derivative gives us the slope of the tangent line, and today we're going to build on that idea and use the derivative to find the equation of the tangent line. And once we have that equation, we can approximate a function value using the equation of the tangent line. You may remember from algebra that we need two things to come up with a linear equation, and those two things are point and slope. And if we put those together, we're going to use the point-slope formula to determine the linear equation. So you may have seen it in this form where our slope m is equal to y minus y1 over x minus x1. So this gives us the equation of the tangent line at point x1, y1. Or you may have seen the point-slope formula in this format, which is basically the same as this equation, but on both sides of the equation, we've multiplied by the denominator x minus x1. So you end up with y minus y1 is equal to the slope m times x minus x1. In calculus, I prefer to use this, what I call kind of a stacked or a quotient formula for point slope, because its format is consistent with so many of the formulas we've already learned and used in calculus, like average rate of change or the difference quotient. But certainly if you prefer this format of the formula, you're welcome to use it. And really, once we start solving, we are always going to multiply by that x minus x1 denominator. So this basically is the second step. So if you'd like to jump into that, you're more than welcome to do so. So taking this formula we know from algebra, let's convert it into a more calculus notation. We know that slope in calculus is found using the first derivative, so that m notation becomes the f prime of c, and then we still have the y minus y over x minus x, but instead of x1, y1, we're going to use c and f of c, so just a fancier way of writing the point at c, f of c, but just know that the basic setup or structure of the formula remains the same. So let's look at our first example, and it is a released AP exam question. So we're going to skim the information given to us, and as soon as we see in the question that it's asking for an equation of a tangent line, we'll know we need to start looking for both a point and a slope. I do want you to notate or highlight what function they're asking you to attach the tangent line, because in some AP questions you're going to have more than one function that you're juggling, so it's really important to identify which one the tangent line is attached to. So the first thing I need to look for is a point, and in the information in the question we're only given the x value of my point. So I'm going to have to use that x value and substitute it into my original function to get the corresponding y value of my point. So after some quick calculations, I came up with f of 1 equals 2, so 2 is our y value of our point. So 1, 2 is our point. Our next ingredient that we need for an equation is the slope, and we know in calculus that the slope comes from the first derivative of our function. As I look back at our function, I see we have a little bit of a complicated function. It is a product left-right, and there is a chain rule in our left function. So let's go ahead and set up our product rule for our derivative. So just to identify all the parts of my product, I copy my left, my d right was just 1, plus I copy my right, my d left was a little more complicated with that power rule 5 coming down, 2x minus 1 to the 4th, and the inside chain rule of 2x minus 1 was 2. Instead of simplifying this with all the algebra, since we have a value for x, I think it would be faster and more efficient for us to go ahead and substitute the 1 in for x, go ahead and do all of our arithmetic, and I came up with f prime of 1, or our slope, is 21. And since we have a multiple choice situation, I noticed that a and b are the only answers that have a linear slope of 21. So we're down to 2 choices for our answer. So we'll put our point slope together in our formula and come up with our equation. Since I'm running out of space, I didn't want to take up space copying the formula over, so let's just go ahead and relate it back to what I substituted in. So our derivative that we just found is 21. That goes on the left side of the equation. In my difference quotient, I have y minus my y value, which we found to be 2, over x minus my x value, which was given to us as 1. So now I'm going to solve this and come up with a linear equation. The first step is to multiply both sides by the denominator x minus 1. Once I multiply both sides by that x minus 1 denominator, I end up with this form of the formula, which is where some of you might choose to start, and that's perfectly fine. You distribute the slope of 21, you add the 2 to the left side, and you come up with the final answer of b, 21x minus 19. So now that we've finished our first example, just stand back and look at the big picture. We basically have 3 steps. We find the point, we find the slope, and then we put those both into the formula for point slope of a linear equation, and we solve for the equation. So as we look at our second example, you'll see that the information and the way the question is presented looks totally different, but they're still asking us for the equation of the tangent line to graph f, and we will still identify these basic components, the point and the slope, put them together and get the equation. So I noticed that they gave me again just the x value of the point, and although I was given the original and the derivative, I will use the derivative to find the slope. So we'll start with the point. We know the x value is e squared, and to get the point, we always substitute that x value back into the original. That would give us the natural log of e squared over e squared. We now have a couple log properties that we need to be aware of. First of all, since the natural log and the exponential function are inverses, they automatically cancel each other out when you put them together. And then when those cancel out, this exponent of the log function, which is 2, drops down and becomes a coefficient. And I know that looks like a power rule derivative, but it's actually not a derivative at all. It's one of the kind of unique properties of log functions that exponents can jump to coefficient spots and vice versa. So long story short, we end up with a numerator of 2 and a denominator of e squared for our y value. My next step is to find my slope using the first derivative. So we'll substitute the e squared x value into my first derivative. So 1 minus the natural log of e squared. We're going to have that cancellation, and the 2 will come down again. And then the denominator, we have e squared, which is being squared. So after simplifying the numerator, 1 minus 2, you get negative 1 over e to the 4th. So not the prettiest y value and slope value we've ever worked with, but let's go ahead and apply them and put them in our equation formula. Since I had a little more space here, I went ahead and copied our formula so we can reference it. Our slope, or the derivative, goes on the left side, so negative 1 over e to the 4th. Then on the right side, we have y minus f of c, or y minus y, so y minus 2 over e squared, and then over x minus our x value of e squared. We will start the same way. Once you set up your formula, you will always multiply by the denominator on both sides. Once I multiply by my denominator, x minus e squared, I am going to need to distribute that negative 1 over e to the 4th slope into that x minus e squared, which is not the easiest thing to do. The first term is not too bad. It just becomes a numerator of negative x over e to the 4th. Then I notice my double negative makes a positive. This e squared, remember, is a numerator, and it's going to be over e to the 4th. So e squared over e to the 4th reduces to 1 over e squared. So it looks like we have kind of a mess here, but when you think about solving for y, it actually turns out to be a good thing. So we have 1 over e squared, and we're going to add 2 over e squared to that, which are like terms. When we do that, we get 3 over e squared. So our final answer for our tangent line is y equals negative x e to the 4th plus 3 over e squared. So probably a linear equation unlike you've ever seen before, but it is the right answer. In the time left, I want to just introduce this next problem. We are given a curve, x squared plus 2x plus y to the 4th plus 4y equals 5. It doesn't have a name like f of x, but they're asking for the equation of the tangent line to this curve. They give us the point x and y, which is very nice because they know the slope is going to take a little more work. We've got to do the implicit derivative of this equation to get the slope, and then try to find the equation. So I'd like you to go ahead and try that implicit derivative. It's good practice. And once you have that, use the slope and the point to set up your equation, and that's the first thing we'll check in class together.